Number 1, sodium being unstable decay into stable sodium if nuclear mass of unstable and unstable is this and mass of electron is this, then find approximate kinetic energy of emitted electron. So equation will be 10 sodium 23 is 11 sodium 23 plus 1 beta particle or electron. Now this side mass is 22.994466 and this mass and this mass total mass is 22.989770 and 0.300545. This is 22.990315. Now mass defect delta M is this minus this 22.990315 is equal to 0.004151. This is delta M. So energy is equal to delta mc square, or if this mass is in atomic mass unit, we can directly delta m into 931 mega electron volt. If we multiply this number with 931, we will get 3.863 mega electron volt. Option D. Now question number 2. A nucleus rupture into two nuclear parts which have their velocity ratio equal to V1 by V2 is 2 by 1, and from momentum conservation M1 V1 is equal to M2 V2. So M1 by M2 is V2 by V1 is equal to 1 by 2, and the mass is directly proportional to cube of radius. So R1 by R2 is equal to 1 by 2 raised 1 by 3. Option D. Question number 3. The radioactive decay, first element is this, then Z plus 1 Ya, then Z minus 1 Ka minus 4, then Z minus Ka minus 4. Here atomic number is increases, so there will be a beta emission, and here number is decreases by 2 and mass number decreases by 4, means there is alpha decay, and here no change in Z and A, so gamma emission. The particles are beta, alpha and gamma. Option B. Question number 4. Potential difference delta V is 2 volt is applied between the opposite faces of a germanium crystal plate area 1 centimeter square and thickness is 0.5 mm. If the concentration of electrons is 2 into 10 raised to 19 per meter cube and mobilities of electron and holes mu E is and mu H is the current flowing through to I is equal to NEA VDE plus NH. NE and NH are same, so we can say VDH. Drift velocity is mu E. So NEA mu E plus mu H into electric field E, and electric field is V by D. Now NEA, mu E, mu H, V and D all are given. Finally, after putting the values, we will get 0.64 ampere. Option D. Question number 5. The atomic weight of carbon from a sample is obtained 12.2 AMU, assuming isotopes C12 and C14 to be present. The ratio of C12 and so total we know total mass 12.2 is equal to fraction of C12. Assume fraction of C12 is X and fraction of C14 is 1 minus X. Total is 1, so remaining fraction is 1 minus X into 14. So we will get 12.2 is equal to 12x minus 2x plus 14. This is 2x is equal to 1.8. So x is equal to 0.9 and 1 minus x is 0.1. So ratio is 9/1. Option A. Question number 6. Lithium 7 plus H1 is equal to 2He4 plus Q. Binding energy of lithium is 5.6 mega electron volt and for helium is 7.06 mega electron volt. And binding energy per nucleon इसमें नहीं होगा, only one nucleon is there, so इसका 0 है. Now Q is equal to binding energy right hand side minus binding energy left hand side. Binding energy right hand side, total number of nucleon 8 into binding energy per nucleon minus this side nucleons are 7 and binding energy per nucleon is 5.6. To solve, we will get 7.3 mega electron. Question number 7. This is A, this is B. So input of this gas, this is NAND gate. So output is A bar. This will work as an NOT gate. And this is also inputs are same and this is a NOR gate. So output is B bar. Now this is B and this is A bar and this is a NAND gate. So A bar B ka whole bar and this is AB bar ka whole bar. Now this is a NOT gate. Output is A bar B and this is AB bar and this is NOR and NOT. So this NOT will cancel out and output will be AB bar plus A bar B. This is output of XOR, exclusive OR. Option C. Question number 8. Pure semiconductor has equal electron and hole concentration. Ne and NH is 10^16. Doping by indium increases NH to 4.5 into 10^22. What is the concentration of electrons? So any NH from mass action law is equal to Ni square. So Ne is equal to Ni square upon NH. 10^16, 10^16. 10 by 4.5 into 10 raised to 9. This is 2.2 10 raised to 9. Option C. Question number 9. In a half-wave rectified sinusoidal output, the peak value voltage is V naught. This is the output of an half-wave rectifier. Peak value is V naught. So RMS value Vrms square into total time T is equal to Vrms 1 square into T1 plus Vrms 2 into T2. This time there is no voltage or no current in second half, so this will be 0. And RMS value of this first half is Vr by root 2 or V naught by root 2 square, and time is T by 2. This is Vrms. So Vrms is V naught by 2. Option B. Question number 10. Not get, not get. This is OR gate. This is A, this is B, this is A bar, this is B bar, this is A bar plus B bar. So when input is 1, 1, output will be 0. This is 0, so note is 1. This is 0, so 1. This is 0, so 1. So in starting, output will be 0, then here 1, here also 1, 1. So option A, 0, then 1, 1. Question number 11. The intrinsic concentration of electron and holes are this at 300 Kelvin. Ni is 2 into 10 raised to 13 per centimeter cube. If the germanium is doped with phosphorus atom with dopant concentration of this, the whole concentration NH is again same, Ni square upon Ne. You will get 4 into 10 raised to 10. Question number 12. With an AC input from 50 Hz power line, input frequency is 50 Hz. The ripple frequency, so 50 Hz in DC output of half wave as well as full. Okay, if output is half wave, frequency will be same, but time period remains same, so frequency 50 Hz. And for full wave rectifier, time period becomes half, frequency becomes double. So 50 Hz in DC output of half wave and 100 Hz in DC output of full wave. Option C. Question number 13. This voltage is 0, this will be 2, and this is 1 volt. So this diode is in reverse bias. There will be no current. So option A, 0. Question number 14. Accession A, the density of the copper nucleus is greater than that of the carbon. No, density of nucleus is a constant quantity. So accession is wrong. Reason, the nucleus of mass number A has a radius proportional to A raised to 1 by 3. Correct. So accession is wrong. Reason is correct. Option C. 15. match the list 1 with list 2. First option, we are imparting a neutron on a uranium. So this reaction is a fission reaction. So A third, A3, then B 2H2 plus O2 is 2H2O. This is a chemical reaction. So B is connected to 1. So A3B1 C reaction is a fusion reaction. Hydrogen and hydrogen are making a helium nucleus. C is a fission reaction, and D is also a fusion reaction. So A3B1 C2 and D4. Option B. 16. Energy release when two deuterons fuse to form a helium nucleus. So 1H2 plus 1H2 is making helium plus releasing some energy. So Q is equal to binding energy right hand side, number of nucleons into binding energy of helium. Helium binding energy is 7, and this side binding energy hydrogen 1.1. This is 5.9 into 4, 23.6 mega electron. Option C. Question number 17. If M naught is mass of isotope of boron, Mp and Mn are the mass of proton and neutron, then nuclear binding energy of isotopes. So in boron, 5 5b12, number of protons are 5 and number of neutrons are 12 minus 5, 7, and 5 mp plus 7 mn are making a boron nucleus. And this mass is m naught. So mass defect is delta m is 5 mp plus 7 mn minus m naught, and energy is delta m into c square is equal to 5 mp plus 7 mn minus m naught into c square. Option A. Question number 18. The energy equivalent to 1 gram of substance. So we know energy of 1.6710 raised to minus 27 kg is 931 mega electron volt. So with respect to 1 gram, this is, we can write this is as 3. So 24 gram is equal to this. So 1 gram is 931 divided by 1.6710 raised to minus 24. You get 5.610 raised to 26 mega electron volt. Option A. 19. Binding energy of a certain nucleus is this. How much is the difference between total mass of all the nucleons and nuclear mass of the, so we need delta m. Delta m into c square is 18 into 10 raised to 8 joule. Now delta m is 18 into 10 raised to 8 upon 3 into 10 raised to 8 ka whole square. This is 9 to 16, 8. So 2 into 10 raised to minus 8 kg. And in gram, 2 into 10 raised to minus 5 gram, or we can say 20 into 10 raised to minus 6 gram, 20 microgram. Option A. Question number 20. For a nucleus AXZ having mass number A and atomic number Z, the surface energy per nucleon. Okay, surface energy is directly proportional to surface area, and surface area is directly proportional to R square. This is proportional to A raised to 2 by 3. So option A is correct. Then B, the Coulomb contribution to the binding energy. No. Coulomb contribution for electron and nucleus is Z, and this is ZE and E. So ZE is square. So B is not correct. C is the volume energy. Volume energy is directly proportional to volume, means directly proportional to A. Is C is also correct. B correct, C correct. No, A correct and C correct. D, decrease in the binding energy is proportional to surface area. No. While estimating the surface energy, it is assumed that each nucleons interact with 12 nucleons. No. So choose the most appropriate answer from the option given below. Surface energy per nucleon. This is not correct. Coulomb force. This is not correct. The volume energy is correct. C is correct. This one is not correct. D, decrease in the binding energy is proportional to surface area. This is also correct. So C and D. Option A. C and D are correct. In the circuit shown in the figure, the maximum output voltage V0 is so for positive half cycle, this diode is in forward condition, this one, and this D1 is in reversed condition. So there will be no current through D1. Current will pass through this here and here. So 10 volt is across these 2 points. Peak value is 10 volt. So peak value across 2 kilo ohm is 5 volt. And for negative half cycle, this is in forward bias. So again, current will flow through this. Again 2 and 2. Peak value is 5 volt. So answer is peak value of output voltage is 5 volt. Question number 22. In full wave rectifier circuit operating from 50 Hz main frequency, the fundamental frequency in ripple full wave rectifier input frequency is 50 Hz, output frequency will be 100 Hz. Answer is 100. 23. The resistance of a germanium junction diode whose Vi is shown as Vk is 0.3. Graph is like this. This is 2.3 volt. This is 0.3 volt. This is 10 milliampere. So R is delta V by delta I. Delta V is 2. Delta I is 10 milli. So this is 200 ohm. 24. So this voltage is higher than this voltage. So this diode is in forward bias and this is in reverse bias. So this will be in open circuit condition and this is short circuit. Net resistance is 10 and 15 in series. 10 into 15 divided by 10 plus 15, 150 by 20, 6 ohm, 25. The acceptor level of a p-type semiconductor is 6 electron volt. The maximum wavelength of the light which can create a hole. So lambda is equal to Hc value given 12.42 divided by energy in electron volt 6. This will be 207 nanometer. A light emitting diode is fabricated using a gallium arsenic semiconducting material whose band gap is this. Delta Eg is 1.42 electron volt. The wavelength of light, same formula, lambda is 12.1242 upon 1.42 875 nanometer. The output voltage in the following circuit. So this voltage is 0. This is 5 volt, this is 0 volt. So this is in forward bias condition and this there will be no current in this diode. So in short circuit condition, this V out becomes V earth 0 volt. Answer is 0. If the potential barrier across a PN junction is 0.6, barrier potential is 0.6 volt, then the electron field intensity in the depletion region having width 6 into 10 raised to minus 6 meter. So E is equal to V by D. 0.6 divided by 0.6 into 10 raised to minus 5. This is 1 into 10 raised to 5. And so answer is 1. 29. The mass number of nucleus having radius equal to half of the radius of nucleus with mass number. So mass number find करना है. Radius r of that nucleus is half of radius of a nucleus of mass number 192. So we can write this as r naught a by 2q whole raised to 3. This is new mass number. A dash is a upon 8. 192 upon 8. 24. Question number 30. Potential divider circuit is connected with the DC source of 20 volt. A light emitting diode of low in voltage 1.8. This voltage is 1.8 volt. And a Zener diode of breakdown voltage is 3.2 volt. Now this total volt this total voltage becomes 5 volt. So this voltage is 5 volt and this remaining voltage is 15 volt. The length of the resistive wire is 20 centimeter. This is 20 centimeter. The minimum length of PQ to just glow the LED. So total length is 20 centimeter and total voltage is 20 volt. So this length becomes 5 centimeter. PQ length is 5 centimeter. 31. The ratio of density of oxygen nucleus and helium nucleus 1:1. Nucleus density is a constant quantity. A Zener diode with 5 volt Zener voltage is used to regulate an unregulated DC voltage input of 25 volt. For a 400 resistor connected in series, the Zener current is found to be 4 times load current. So we have a battery of 25 volt. Series resistance is 400 ohm. This is connected to a Zener and load resistance is always connected to parallel. Zener breakdown voltage is 5 volt. This total voltage is 25 volt. So this volt becomes 20 volt. And current condition is the Zener current is found to be 4 times load current. Load current is I, then this current is 4I. So total current becomes 5I. So 5I is equal to 20 divided by 400. 1 by 20. This becomes 0.05 ampere. So I is 0.01 ampere. Or we can say 10 milliampere. So load current is 10 milliampere and load resistance, we know voltage across load resistance. V R is V by I. V is 5 volt and I is 0.01. This becomes 500. Option C. In the given circuit, the voltage across load resistance RL. This is RL. So voltage is IR. So first we want I. This is 15 germanium. Barrier potential is 0.3 volt. This is 0.7 volt. So there will be a drop of 1 voltage across both the diodes. Remaining voltage is 14 volt and total this resistance is 4 kilo ohm. So load voltage is IR 14 by 4 into 2.5. In a given circuit, the current through the battery I. So this diode is in forward condition. So short circuit this diode and this is in reverse bias. So remove this wire. This will be in open circuit condition, and this is again short circuit condition. So 10 and 10 are in series. This becomes 20, 20 and 10 are in parallel. Net resistance is 20 by 3, and I is V by R, 1.5 35. This is 12 volt. Current will pass through germanium diode. Why? This barrier potential is smaller for germanium compared to silicon. So there will be a drop of 0.3 volt. So this voltage becomes 11.7 volt. Output voltage across 10 kilo ohm is 11.7 volt. So for negative potential, this diode is in reverse bias. There will be no output. And from 0 to plus 5, we will get output. So output is from 0 to 5. Option A. In the ratio of concentration of electron that of hole in a semiconductor, Ne by NH is 7 by 5. And the ratio of currents IE upon IH is 7 by 4. Then what is the ratio of that drift velocity? So I is equal to NE VD, NHE VD H. So VD electron by VD hole 7 by 4 into NH by NE is 5 by 7, 5 by 4. Option D. A nucleus X is initially at rest, undergoes alpha decay according to the equation. This is 2He4. So ये कितना होगा 228. A is 228. This Z is 92. Now in explosion, moments of both the parts, of both the particles are same. And kinetic energy of each part. Kinetic energy of alpha particle is P square by 2 M alpha. M alpha is 4. The kinetic energy of this Y is P square upon 2 into 228. Now ratio of K alpha by Ky is 228 by 4. Now K alpha upon K total, fractional energy of alpha particle is 228 upon 228 plus 4. 228 by 232. Option B. 39. It has been observed that the most stable nuclei have generally the neutron to proton ratio is 1:1. Option D. In the following circuit, find I1 and I2. So in forward bias, this is short circuited. So there will be no current in 12 kilo, no current. And again, they are short circuited. So no current in 14 kilo ohm resistance. So I1 is 0 and I2 is no net current in this circuit. So I2 is 10 upon 2 kilo, so 5 milliampere. I1 is 0 and I2 is 5 milliampere. Option D.